Okay, so today is the second session of teaching by SM. Please like and subscribe the channel. All the all the earnings from this will be contributed to the Palestinian and the Lebanese cause. Let's move on. The question asks us to find the total surface area of the solid. The solid is made up of three things. Number one, this hemisphere. Number two, this cylinder. And number three, this circle. We won't count this circle, you might be wondering, and that is only because of the fact that this circle already has the hemisphere on top of it. It's not a surface. Now we're simply going to put the areas and calculate it, right? So they have given us the surface area of a sphere, right? It's going to be divided by 2. So SA of sphere plus surface area of the cylinder, which is in actuality it is the circumference multiplied by the height, right? And last but not the least, but the area of this third surface, which is circle. So pi r square h over 2 plus 2 pi r h plus pi r squared. So 4 into pi r 4 into pi r square, which is 7 squared over 2 plus 2 into pi, radius is again 7 into height, which is 12 plus pi into again r squared, which again is 7. So 7 squared, right? Once we calculate all this, it comes to 315 pi or 989.60 centimeter squared. Let's move forward. Now, I hope this question is clear. 3 surfaces, so let me mark all of them again. Sphere, marking it brown. Cylinder, pink was not the wisest choice. Blue, circle. Okay, they are telling us that the area of triangle ABC is 27 and the base AB is 6. Now they're asking us to find the height h. And questions like these, what we need to understand and realize actually is the fact that because they have given us the area, right, the fact that area is changing, it does not change any single thing, right? Area remains the same no matter what. So because height will remain the same, right, understand the fact that dimensions does not change, right? So we can say that whatever the area is, it should be equal to some base 6 multiplied by some height, which you do not know, correct? Why? Because this statement is true in its own self, right? 6 is a base, that is a fact. 27 is the area of this triangle, which is a fact again pointed out by the question. So we just need to find that height, right? So we can simply solve it, make h the subject, and get an answer. I hope it's clear, guys. Again, you can apply the formula of the area and simply get your answer. Why? Because applying a formula and putting in the conditions we need will always yield us the result that we are going to need if the shape is correct and if the formula implemented is for that particular shape. There are two ways to calculate the area of sector, right? We are going to use theta over 360 into pi r squared. Theta is 60 into pi into r squared. So 1 over 6 pi into r squared is 56.25 into pi divided by 6, that is equal to 29.45. I hope it's clear, guys. Right? The question says that a paperweight has height 4 and volume 38.4, right? A mathematically similar paperweight has height 7. Because they are similar, we can take the ratios of their lengths and volumes. The formula is L1 over L2, V1 over V2 is equal to the cube of L1 L2, right? And that is actually how we're going to do the question, right? So we want to find V1, right? This is the volume of the larger paper, so we do 38.4, and then we want to equate it with 64 over cube of 7, it is 343, and multiply it. Oh, sorry, my bad. It's the inverse relationship. Sorry. L2 over L1, guys, my bad. Right? So, the inverse of it, and you can multiply that 38.4 into 7 cube over 4 cube, and this should give us 8.4 into 7 cube 4 cube, and we have our answer 205.8. My bad, I labeled it wrong. Now guys, we are here to find the in the question above, this is the ratio that it has to be used. It's the inverse ratio of lengths, right? So we use this formula and we put the volume to find our interested volume, that is V1. Here we see a sector OAB and this sector has a center O, and it is said that radius is OB. and they've told us the center of the circle, right? One thing that we need to realize is the fact that okay, this is 60, right? Regardless of them telling us. They're asking us to find AP. This is quite simple. We can simply apply cos. So cos 60 is equals to perpendicular. Sorry. They want us to find AP. Right, so first we need to find OP, right? That is the thing that we need to find. So we need to find the base. So again, cos 60. No, we need to find sin 60. My bad, guys. So sin 60 is equals to OP over hypotenuse, that is 8. So OP is equal to 8 sin 60. This gives the value equal to 6.928. We need to understand that the entire OA comprises of two lengths, OP plus PA or AP. We know that OA is entirely 8 and OP is 6.928 plus AP or PA, however you want to name it, right? So if I simply subtract them, then I should get my answer, right? So I simply subtract this from 8 and get my answer. It is equal to 1.0718. So 1.07 centimeter, guys. Right? Just move forward. Then they're asking us to find the height of the shaded region. This is even more easy, right? There are two ways we can do it. The best way is to find the area of the sector, right? And then to find the area of the triangle, right? So shaded area is equal to area of sector minus area of triangle BOP. So what's the area of sector? Half into r squared into half r squared theta, right? So for that we need to convert theta into radians. So the better way to do is this. Simply do into theta over 360 into pi r squared, the area we used in the previous question, minus area of a triangle. We can simply use half AB sin C. So AB are the lengths that make the ratio, that make the angle. So our angle is 30, and we know the lengths making it. So length A is OB, which is 8. Length B is OP, which is 6.92928, the one we found above, multiplied by sin 30. Once we simplify them, this becomes 16 over pi subtracted by 13.856. So our answer becomes equal to 2.899, or you can simply write 2.90. Okay, let's move forward, guys. they're saying a diagram shows that a diagram shows a shape made from an equilateral triangle ABC. So it's an equilateral triangle, it means all the lengths are equal. This means that AB is a radius, AC is a radius, and BC is also equal to radius because A is the center of the circle, right? They have given us the entire thing, right? So we can conclude, so they're asking us to find the perimeter of the entire shape. What we need to understand is that in giving this length, they've also told us that all the angles are equal. So this is 60 and this all is 300 degrees, and the radius of this triangle in the radius is 12.4. So we already know this is 12.4. We just need to find the length all the way going from B to C. Right? And how we do it? By parameter. The formula is theta or 260 into 2 pi r. Theta is 300 of our major sector multiplied by 2 multiplied pi multiplied by side length is 12.4 plus the length BC is already 12.4. Right? So when we simplify it, guys, this becomes equal to 64.9 plus 12.4. This becomes equal to 77.326. They're showing us the diagram of two circles, right? So obviously one circle is this, right? The other sector is the one that they have not drawn, but it is this. So it's basically 319, right? How did I get it? Simple, 360 minus 41, right? They're giving us the area of the major sector, right? So it's easy, right, guys? How? The formula for the major sector would be, area of major sector would be 319 over 360 into pi into r squared is equal to 74.5. Now we can simply make r squared the subject. So r squared is equal to 74.5. This was dividing, so goes to here to multiply. Rest of multiplying, so go there to divide. We take the root of it by taking square root on both the sides. And this gives us our answer. So the radius of our sector is 5.173. You can convert it into radians and do it as well, but it's easier to do it in degrees since the question doesn't mention that we need to convert it into radians. So it's simple and won't have any additional step. Otherwise we had to add another additional step, that would be converting it into radians first, and that does not make any sense to do it because it's an additional step that shouldn't be done in the first place. Let's move over here. The question tells us the radius, right? And they're asking us to find the perimeter of the shaded region. So understand that the perimeter consists of two things. Number one, the perimeter of shaded region consists of this, the arc length, and then it consists of this, right? These are two different things that it consists of. Now the thing is that it is simple and again fairly easy to find the perimeter of the shaded region, right? Fairly simple and plain way to find the perimeter of the shaded region, right? The first thing that we are going to do is we are first going to convert this into radians, right? Just a minute, guys. Pencil. Okay, thank you. So let's just first convert it into radians to make our lives easy. Right? There are two ways to do it. One is you convert it into radians and then get the arc length, right? The other method is you simply employ this formula. Pi over 360 into pi into r squared, right? These are two different methods that can be done and that can be achieved. Since this was simple, I achieved this. Otherwise we would have had to convert it and then get our answer, right? Simple methods are the ones that are always preferred, and because they're easy to understand and easy to execute. So this gives us 17.593. Now this is our first length that we can do to find this. Now the second way to find and get the second way is that we find this length, right? Another thing to understand and realize is that by observation you can tell that this region, this 12.5, this length, I hope you guys can see it, that this length may not seem equal to this length. So the best way to understand and find anything like this is that you cannot judge it, right? O is the center, so this is going to be 12.6 as well, right? Now what we can simply do is that we can apply a magnitude of different formulas to it, right? Some of you will say apply cosine rule, some of you will say apply sine rule. Sine rule could have been applied, right, but it will be a bit long, because again we do not know the length of this, right? So for sine rule you must know either of the things, right? So if you apply sine rule between these areas, it cannot be done, right? But what can be argued is that because these two lengths represent the same area, they are going to have the same lengths, right? And this is something that can be argued about them. This is debatable as well, right? This is also debatable. So the thing, because again we do not have let's say very concrete evidence of them being similar, right? This puts us again back to square one, because we do not have a concrete evidence that they are going to be equal or that they are going to be similar or same in nature, right? So how can we do it? The best practice and the easiest way to do it, guys, the easiest way is make a right angle triangle out of this. This is the easiest approach there is. That takes away all your problems, right? That this addresses all your problems. If you see a case like this and you aren't sure, simply take a right angle triangle, right? A right angle triangle is a bisector. As per us, so it's our own assumption because we are going to say that this takes 40. So if it divides the angle by 2, this means the length is also divided by 2 and is equally distributed. So let's call this area PD. So how to find the length of PD, right? We need to understand that length of PD can be easily found out by applying the sine rule, right? So PD is equal to sine 40 multiplied by 12.6. And since the entire length is twice of PD, to find the actual parameter, you can multiply this all with 2 and then add this 17.593 to it. Sine 40 12.6 into 2 plus 17.593. This is 33.79. Right? I hope it makes sense. Was the first approach, would the first approach be right? No. And this is why we always fall back to the perfect approach, the approach that will give us consistent answers. Why? Because we do not know what is in the marking scheme. So we at our end have to ensure that we are always going for the fail-proof method. So we cannot assume that these lengths are equal. That is why we never take the risk. That is why some people who might have thought to do it that way might have been wrong. Right? So the best way is always make a right angle triangle out of it, a perpendicular triangle, and then solve your way through it. Now they are saying find the radius of a hemisphere whose volume is this. So volume of hemisphere is the given volume. We'll make radius a subject, so 80 multiplied by 3 or 4 pi (240) or 4 pi, right? So it should be 60 over pi, but anyways 4 pi, right? So we get an answer of radius that is supposed to be 2.67. Right? But what we forget about it is that this is an area of a hemisphere, right? So to find the area of the sphere, we have to double it, right? So it actually becomes 160. Sorry, just read it, guys. So let's rectify this as well. So I think 480, yes, 480 will be there. 480 over 4 pi, right? So that is 3.367, right? How do I know that I'm making a mistake? It's just the fact and sometimes a sanity check that if a hemisphere has volume 40, the radius cannot be that low, which is why it led to me to cross check. The other thing that I could have done is, if not multiplying by 2 and keeping it simple, is that I could have just divided this volume by half. So it would have become 2 over 3 pi r cube is equal to 80, right? And then similar thing, the only thing that would have changed is this 240 over 2 pi. Either approach is going to give us the similar answer. It says a cuboid measures this, right? And they're actually asking us to find the diagonal length of a cuboid, right? So the first things first is that in order to understand that how to find the diagonal length, we have to see what we can do, right? Now there are multiple approaches to it, right? So let me try to draw a cuboid. Right, again the drawing skill isn't great, guys, so please cut me a slack over this one. I know this doesn't remotely look like a cuboid, and I apologize for that as well. But yes, this is the best that I can do, guys. Right, so again, the very simple method of finding a diagonal of a cuboid is simply by taking the square roots of all the lengths, right? Or taking squared of all the lengths and then adding it up all together, right? But the easiest approach is taking the root of all of them, right? So diagonal will be equal to square root of squared of all of these, and this gives 28, right? You can apply multiple approaches, right? You can take different and then add up, right? But this is the easiest way it can be done in order to do it through an efficient manner, guys. They're asking us to find a total surface area of a cuboid with length, breadth. Now I'm just going to copy the cuboid from the top. Makes my life easy. And yeah, it's a bad drawing, I know. I'm really sorry for it, right? So it has 3 faces, right? 1, 2 and 3. What I'm going to do is I'm going to make a combination of all of them, right? And take 2 of them. So let's say this is 6, this is 8 and this is 3, right? So one face is 6 times 8, right? The other face is 6 times 3, and the other face is 8 times 3, right? Which is this phase. Second phase, first and third phase, right? And then there are 2 of all of these. So there is 2 of all of these, right? This is 48 plus 18 plus 24, right? So this becomes 66 plus 24 is 90, and this becomes equal to 180, guys. Question 36, let's read it through. The diagram shows a solid metal shape made from a cone and a hemisphere. So cone is on the bottom, hemisphere is on the top. Both of them have the radius 6.2. Total surface area is again 600, right? And they've given us a surface, and they're asking us to find the slant height of the cone, right? The question is fairly simple. They have provided us with all the important things, right? And we simply have to equate, right? The only thing that we need to change in our concept is that the area they've given us is of a sphere, and we have to make it area of a hemisphere, right? So area is equal to area of hemisphere, which is this, plus area of cone, right? Once I solve this, it comes equal to 8.404. 18.404, and you can set it stop at 18.4 or 18.40. In this question, they are asking us to find the dynamics of the square ABCD. Sorry guys, with length k. So this is k, this k, k, k. It's a square, so all lengths are equal. And they are asking us that MD is at a circle with center D. E is a diagonal. Okay, diagonal means it's going to cut our angle, right? And they've already told us that M is the midpoint, so this means that MD is half K and ED is half K as well, right? So the best thing that we're going to do is we are going to find the area of this, right? Because the diagonal, it cuts the 19 to half, so this is 45. So let's find the area of the sector. So area of sector is half over 360 into pi into r squared, is half k, right? So let's simplify it. So it becomes 1 over 8 pi into 1 over 4k squared. So it is pi 32 over k squared, right? This is the area of the unshaded region, right? And what is the total area? The total area is k squared, right? So let's find the out of total, let's find the shaded area, right? So the shaded area is equal to k squared minus this. So if I take k squared common, it becomes this. This is my shaded region, right? Over the total region into 100, right? So shaded region over total, or shaded area over total into 100, right? That gives us our answer. So we do this, right? We solve it and we get the answer 90.18. I hope it makes sense, guys. 90.18%. So this is the shade region. Again, what did I do? Shaded over total into 100, right? I'm highlighting the shaded region by blue. This was our shaded region. They're saying a solid is made by cutting a small cone from a regular and larger cone. So you can see that a larger cone is cut, right? And they're given us the height, a larger one, diameter, and they're asking me to work out of the volume of the solid cone that is there, right? So it's easy. They have given us a diameter, right? We can use a diameter in order to find the radius, right? The radius is what we need for the actual thing, right? And Yes. So you can simply cross multiply. So you can simply cross multiply it and get our answer, right? They're asking us to find the volume of the solid, right? So what do? We find the area of the larger cone and we subtract the area of the smaller, and we subtract the volume of the smaller cone, right? But this would be redundant. Why? Because then we need to find the area of the larger cone, then subtract the smaller, right? Or what we can simply do, an effective way to do is that we can simply just get rid of the height, right? The change in height. So volume is equal to 1 over 2 into pi into r squared, which would be 9.2 over 2 whole squared multiplied by a change in height, because that is the volume of the solid, right? So 12.5, right, minus 5.5. No, wait, we do it separately. The upper cone, the total cone minus, okay, yeah, this is how we can do it. Yes, wait, let me see. We have to find out the area of the, no, this wouldn't give us the volume of the solid. This would give us the volume of the total, no. And have they give us, no, they haven't. If I can do it, if I can make a ratio, they are similar. No, they won't be. Wait a second, guys. This one has got me to think a little bit as well. Let me try a different approach. This will give us the volume of this, but even that won't be right because this is not a cone, right? We know that this height is 7, but what we don't know is the base of it. Just what if we can find the base of it? So just a second, guys. 9.2 divided by 2, 4.6, and this, need to find the angle first, and yeah, we need to find the angle first if we're using that approach, right? And then this angle will be there because it's the horizontal still, so angles on the same line. 2.576. Okay, so this is the best approach, right? That we find that this is the area, right? So this is we find it using 10, right? So we make a right angle out of it, guys, right? And this we know is 12.5, right? And this we know is 4.6, right? So we find this angle, right? So this angle is called the z. So it will be 10z equals to 12.5, 4.6, and z be equal to this, right? And this is equal to 69.796. This angle is going to be same as this, and this helps us to find the radius of the smaller base, right? So that is, let's call this P. So P is equal to the length, that is 7 over 10, 69.796. This is the image for it, right? So this gives us 2.576. So we now have the two radiuses, right? And then we can simply subtract it. So 1 over 3 pi is common in both the volumes, subtracted by what we subtract additional is the product of their heights, right? Into 12.5 minus 2.576 squared into 7, right? I took 1 over 3 pi common because they are constant in both the formulas, right? And the answer we get is 228.34. So let's do this one. They're asking us to calculate the volume of a sphere with diameter 4.8, right? So remember that the formula is only going to give us the radius, right? Sorry, the volume. We need this. It allows us to put radius. So we have to find the radius, which is 2.4. So volume is 4 over 3 into pi into r cube. This is equal to 7.09. Let's move forward. This is showing us a sector, right? And the telling us the diagram shows a shape formed by two sectors of a circle. One is a bigger sector OAB and one is a smaller sector ODC. And they set both angles, which makes sense, they have the same opening, right? And they have to find the area of the shape. So how do you find the area of this shape? You simply find it by subtracting the smaller area with the total area, right? So 1 over 2 pi over 360 into 360 pi into r pi r squared. remember the fact that 360 over pi remains the same. So I'll take that common in both the formulas and subtract the square of the radiuses. Well, the radius of the bigger pi is, because it is 5.8 squared, minus smaller, which is 3.2 squared, right? So let's solve it. This comes equal to 91 over 10 pi. Right now, if we have to give one value because there is no root, then it would be 9.1. Right? Why? Because we have to give the value of k, and k is not a fraction. And if we are giving k as this, it can be 91 over 10. What is prudent? Prudent is to give that 9.1. If there were a denominator, they would show a denominator. Total surface area of a cuboid, the area of all the surfaces, phase 1, phase 2, phase 1, 3, 2, 1, right? So 8 into 5, first, again there are two phases of everything. One is the hidden phase, right? Then second phase, 2 times of 3 into 5. Then the last phase, which is 8 times 3. So 80, 30, 48. 110 plus 48 is 158. This is a simple formula, right? Fairly straightforward to apply the formula. So volume of a cylinder is equal to pi r square h, and this is the volume. This is pi r square h. R is equal to, make r the subject, 1970 over pi into r. This should give us the value of r. We'll input the values of our pi and our h, is 12.2, and this gives us 6.9992, which can be written as 6.99. Right? We simply have to plug in the values from the formula. They had given us the value of the h, and pi is a universal constant, right? Here in this question, we need to realize that we have two cones which are similar cones, right? And between them is a circle, a 2D circle that is uncolored, right? So how do you find it? You find the area of both the regions and subtract the area of a circle, right? So how do you find the area of both the regions? Again, center is B, right? So BC and AC both are 13.6. So the area of triangle BAC is half into 13.6 whole squared multiplied by the angle, that is sine 41. Because there are two, you make this 2, right? This will be subtracted by the circle, right? But the thing is that this circle is not a complete circle, right? This circle is actually an opening, right? An opening at 41, right? So we subtract 41 pi over 360 into pi into r squared, and again the area will be constant for it, so that would be 30.6, right? So let's simplify it again. This is we are dealing as a complete circle, but the circle is opened at an angle of 41, right? It's not a circle at 360. It's a circle that has opened at 41 degrees, right? So we will just solve for it. So let's go. 2 into half into 13.6 squared into sine 41 minus 41 into 360 into pi into this gives the total area from this to be 121.34. This area is giving me a problem, guys. Give me a second. I think I did a typo in my calculator. Let me check. Okay, so what we can do is that we can take an approach that is going to take a bit of time, but let's try to do it, right? So we have the area of triangle BAC, right? What we could have done is we could have taken the area of the rhombus, right? Either thing won't make a difference, right? Now what we need to understand is that in order to get what we want, we need to find the area of the unshaded region, right? So if I can show you how it is something like this in plain sight, right? But this region is overlapping, right? So what we need to do is we need to find this extra of a region, right? And we need to subtract this extra region twice, right? But that is the region, because that is the region that is going to cause us problem, right, guys? So how do we do it? It's simple, right? We have to find this extra area. Let me highlight it. Let me purple. Let me to find this extra area, right? And simply multiply it by twice. Let's find this extra area. right? So when we find this extra area, we simply do area of entire sector, which is this, minus area of triangle, which is what we have done over here, right? So but one times of it, obviously. And the difference is 6.177. Now there are two areas like this. One this, so if I draw over here to show you, once this, second is this, right? So I multiplied by 2. So this, sorry, it's 5.7, it automatically, my bad, 5.507, right? So when I do twice of it, it becomes 11.0146. So out of total triangle, I subtract this 11.106, right? This is 121.34, and I get to my shaded area, which is 121.34. Sorry, minus 11.0146, 110.32. My bad, guys. Centimeter squared. Now we have to find this. We have to find the total surface area of a cylinder, right? Total surface area of a cylinder has two things. It has a cylinder, right? And it has a squared like this, right? Something like this, right? It has two circles, and surface area is this entire perimeter thing, right? So 2 pi r into h to find this cylinder, the perimeter, which is the surface area, plus the area of the circle, which is pi into r squared into 2, because there are two of these, right? So this becomes 80 pi plus 50 pi, 130 pi, right? Now 130 pi can be solved to give us the exact value, which is 408.407. That they have given us the radius and they have given us the density, and just saying find the mass. So first step is finding volume, pretty easy. So volume is this, right? And they've given us the density, right? So simple, density is equals to mass over volume, right? What is the density? Is 0.5 multiplied by the volume divided by 1000. Why? Because density is in grams, you have to convert it into kg, so divided by 1000. just to mass, right? So this multiplied by 8.05 over 1000 gives us the mass, which is 1.573. They have given us the height of cylinder and the curved surface area, right? And they are asking us to find the volume of the cylinder, right? So it's easy. Let's do it. Plus we are going to add the again a curved surface area. A curved surface area means that there is no circle, right? So it's hollow at the ends, right? So we have the value of the h, right? R is equal to 1 over 5 pi over 2 pi h, which is 12.5. So gives us the R is 4.2, right? And then you can use it to find the volume of the cylinder. The formula for cylinder is pi r square h. So pi to r square into h. So cylinders pi r square h, pi into r squared into h, is 12.5, and this is 692.72. And this is the end of it, guys. Hope you guys enjoyed. I hope all of what we did was understandable, right? And I'll see you guys tomorrow in the next video. Please don't forget to like and subscribe the channel. Feel free to leave any feedback that is there. All the proceeds from these videos will be transmitted for the betterment of the Palestinian people.